To begin, we'll start by applying a volume shader to our point cloud. If I open up the Explorer, I'll grab my point cloud and animate material. I'll throw just a throwaway shader on here. So I'll just throw on a blend. And now that I've assigned a shader to my point cloud, I can see in the Explorer that it now inherits a material that I'll call cigarette smoke material. I'll select the point cloud and open a render tree by pressing 7. I can close down my Explorer. So what I want to do is actually control the volume input of the cigarette smoke material, and I'm going to do that by accessing the particle folder of the render tree and applying a base particle volume node to that volume input of the cigarette smoke material. So color output, color input, and the cigarette volume cloud will create a bounding box in the shape of the particle. Actually, the bounding box is very close to what you'll see for the bounding shape around our point cloud. If I draw a render region, that's what I get. So it shows me a bounding box that has density. If I double click on the point cloud or on the particle volume cloud, one of the first attributes that you work with when you're dealing with your particle volume shading is the lookup table. Your lookup table and your density. You'll notice that working the global density, I can also provide a particle density as well. But this pales in comparison to the importance of setting your lookup table correctly. And the problem right now is that we are only dealing with the volume of the entire volume cloud. Volume shading you can kind of think of as a subtractive effect. You have a bounding box in the shape of the min-max sizes in XYZ of the particle cloud, and you want to cut away from that volumic box using the particles you've created. And the lookup table helps you to define the size of the many small boxes that try and replicate that shape. The boxes are called voxels, sort of like volume pixels, volumetric pixels. And we actually shade within those voxels and can texture within those voxels. So right now we have one giant voxel. There are actually more voxels in here, but we can't actually see it till we cut away. So usually when you're using a particle volume cloud, it's easiest to tune the effect by actually plugging a particle density node into the density input of the volume cloud. Right away, you'll notice that, well, a lot is cut away here. So clearly I need to do some work. So the first thing I guess I would try and do is get the density of my effect up high enough so I can tune the shader. If I click on the volume cloud, I can take the lookup table attributes and set the cell interpolation to no interpolation. So what this allows me to do is this allows me to set my voxel size, but again, I'm going to have problems doing that if I don't have enough particle density to try and replicate that shape. I'm getting patches of it, but that's really not good enough. So what I'm going to need to do is increase the size of the particles in the ice tree so there's more overlap. So I'll open up the ice tree by pressing Alt-9. I'll move right to the size attribute, and I'll just kind of minimize a couple of these here. I'll press play, and I'll just increase the size until I have quite a bit more thickness that I can cut out of. Okay, that'll look a lot better. So I'll move my ice tree up here. I might actually need it a little bit later, and I'll reopen my render tree. So let's see what we actually have now. So the volume cloud is getting closer. If I actually open up the particle volume cloud shader again, I can keep reducing the cell size, and now I'm starting to get somewhere. If you look up higher, very faint. The particles are actually starting to die off. So if I keep reducing the cell size, I can start to describe more and more detail. And I'll try and do that as much as possible. If you get too low, you'll actually run out of memory, and that's something that you have to be very careful about. Running out of memory will crash mental ray. So if you set a cell size that's too low, and I'm trying to actually go too low here, there we go, you actually return an error. The cell size will not render, you actually get a warning in your script editor telling you how much memory you would be using if you were to calculate that lookup table. So I'd be using 2 gigs of memory to create that particle density. So I don't want that. I'll take the cell size here and I'll set it back to say 0.2, where I'm getting a lot of fine detail. Let's try going to 0.1. And I think a cell size of 0.1 will work just fine. I can set the interpolation once I'm done creating my lookup table back to linear. So I actually get the smoothing of the effect. If I zoom in a little bit closer, this will be a little more apparent. I can raise the aliasing a little more as well. Now we need to just control the overall density of the effect.